So the first tutorial is going to be all about singletons and how singletons can be used in Unity and how they shouldn't be used in Unity. So let's get into that. So what I have here is a small example of using a singleton in Unity. Now, okay, I expect people to have some programming knowledge already, but I am going to go over what a singleton is quickly first. Why it's useful, why it's not. It is considered by many to be a bit of an anti-pattern. And an anti-pattern is... It's a pattern you shouldn't use. It shouldn't be a go-to pattern. It shouldn't be. It's a tool in your box. There's always all these things that people say you shouldn't use. Oh, they're bad. There absolutely should be a tool in your box that you should have in mind. But they have in the past, currently, like, they get overused and they get put into places where they shouldn't be. When all you have is a hammer, everything looks like a nail sort of situation. But a singleton is useful, and a singleton is a good pattern for doing certain kinds of things. Now, one of the things I want to do in this tutorial is show a very specific Unity-focused version of a singleton, and the singleton pattern, to show that the singleton pattern doesn't just apply to classes. I want to do what's called a singleton prefab. That is a prefab that you will only ever have one of in a scene, and it basically runs off the idea of the singleton pattern. You can only have one of the singleton class, and it will use a singleton. It will use there is a Unity monobehavior singleton pattern which works reasonably well. But I want to quickly go over why you shouldn't be using singletons in Unity, like the traditional singletons. So here is my test project. All of these will be going up on GitHub. This will be going on YouTube. I will be putting a link in the description of the YouTube video to go to that. Hello, not priceless. Welcome to the stream. So, singletons are useful. They are also overused. They are a dangerous pattern to use, and I will be doing it in a very Unity-specific way. So, as I'll get on now, there will be some programming involved, but I will just show you the example singleton. So I've got two classes here doing the singleton thing, which is linked to this button. So this button will go to do the singleton thing and do the singleton thing. If it's a very specific thing, why bother teaching it? Because it's a pattern. The whole point of this tutorial is to go over what singletons are and to give you a specific use case in Unity. So, singleton example, doing the singleton thing. In doing the singleton thing is just a thing that goes off and does the singleton. Now this is not what you should be doing in Unity. This is an example of using a singleton, not incorrectly, but it's not. It goes against the ethos of what Unity does. Unity works with monobehaviors, it works with components, it works with prefabs, it works with game objects. It doesn't. The philosophy of Unity kind of abhors statics, and singleton is all about one thing, it's all about statics. We'll go into the singleton example, and this is a traditional C# singleton. You have the lazy loaded singleton. You never know if the specific thing might happen. Exactly. So But the thing is, it's an idea. You have to keep in mind the tool that's in your box, and when you get a problem, if the singleton is the right way to do it, that's a good way to solve the problem. People keep aborting singletons because of various reasons, but they're still a good tool. But the traditional singleton is not a good tool for Unity because, as I've said, Unity is designed to work off of components, game objects, all that kind of stuff. It's supposed to be it's supposed to be instances of things, whereas a singleton is this god object, which is what the danger is in a singleton. The danger of a singleton is that you just have this one object that does everything, and it's really, really, really tempting just to stick all your code in this singleton and have it run your whole game. But singletons are useful in small instances where you want to do some very specific things that are used everywhere, but also want to store data. You could just have a static class that does things. Unity has various static classes. So, for example, the application class is a static class. It's got a bunch of properties in it. Don't know how Unity stores all this stuff. It might be in a singleton. Who knows? But all of these are single constants, so application data path, all this kind of stuff. Unity uses statics in the back end, but programming wise, you don't want to make a game with statics. So there are other issues with Unity and statics, which I will go into. In fact, actually, we will do it just now, because it is quite an important thing to think about why Unity doesn't like statics. When you hit play in Unity, it takes a couple of seconds there. This is an empty project. 1, 2, 3, 4. Count to 4 and it's playing. Why is that? Because it's doing what's called a domain reload. Now, domain reloads, even in small projects, take ages. Like 4 seconds. Well, okay, not 4 seconds. I counted to 4, it was a bit faster than 4 seconds. But a few seconds for an empty project to load in the editor. Kind of gets a bit frustrating. On larger projects, that gets a lot bigger. Especially when you're coming into it after a while. It does a full reload of all of your code. And it gets a bit nuts. So what Unity has done is in project settings, you can go into somewhere into editor, and down here there are experimental options. So experimental play mode, reload scene, which is important. That doesn't take that long if you've got a small scene. It's the reload domain that we uncheck. Now what this does is it doesn't reload the domain. Now what happens when you reload the domain? It resets all of the static values. So when we press play here, instant. Straight away. No delay. Milliseconds. It's lightning fast not doing the domain reload. That is the biggest slowdown when you're editing in Unity. And it's one of the reasons why statics aren't a good fit for Unity. And what it means is that if you do this singleton example, if you do this way of doing a singleton, that instance will be set. While you're in the editor, any changes you make to this singleton will be static until you reload Unity itself. Which is not great, because the whole point of pressing play in Unity is you think you're getting something completely fresh. So we do have to take that into account when designing in our code. So singletons, definitely an anti-pattern when it comes to Unity. However, there is a way of getting around this. And what we're going to do is we're going to turn this singleton example, because what we're really doing here is this mono behavior is just going off and calling the thing. It's not really, it's decoupled from Unity by one step. What we really want to do is have something in Unity, like this button, clicking on do the singleton thing, and it just does the singleton thing, rather than having a little bit of code that then goes off and does the thing. So what we're going to do is we're going to create a new object. We're going to call this a Singleton object. I'm going to add a new component to it called Singleton component. And this is going to be a Singleton component. It's going to be a mono behavior. It's going to be on things. It means that we can directly go into things and hook it up in Unity, like we did with the button. So we use the inbuilt inspector to do things. So we're working within Unity and we're working to Unity's strengths. Now, what we need to do is think about what a singleton is. There can only be one instance of a singleton. The problem with that is that this singleton component is now attached to a game object. So how do we want to deal with that? So if I duplicate that, there's now two instances of singleton component. There's not much you can do about that. If someone decides to go in there and create two singleton objects, because the public constructor of because a component's public constructor has to be public. Like, you can't make a private constructor. That's the whole point of a singleton. The singleton example has a private constructor, which means that only the singleton example class can make a new one of itself, which means it's entirely self-contained. And it means that nothing out there can do it. So the singleton component has to be aware of itself and has to actively delete any new ones. So what we need to do first is design around the singleton pattern. So public static singleton component instance. We also want a private static singleton component instance. And in here, we want to do the get. Now, you'll notice that in the other example, we're using the lazy. That's because it's a simple class. We could use that for this, but generally speaking, we can get away with doing it this way. There are weird things about how Unity determines whether things are null, which is another thing we have to get into, and we will be using this first. So what we'll do is, if instance is null, if we're trying to get an instance and it's null, we want to go off and get a new one. So how do we find a new one? Well, we want to do instance equals find object of type singleton component. So far so good. If there's one existing in the scene, it'll go off and get it. But what if it's still null? Well, then we want to create a new game object and attach a singleton component to it. So we'll do that. And what we can also do in here is we can give it a bunch of types. So that will create a game object with a new singleton component on it. Now, what we then do is we return instance. The problem with that is that we then have to go and set instance to go.getComponent, which is a bit heavy. So what we do is we go.add component, singleton component, and we get a reference straight away. So this is the basis of the singleton pattern in Unity. So on awake, so this is the Unity lifecycle event. We don't want it in the constructor because the constructor gets called in the editor. So the moment you add the component to an object in the editor, the constructor gets called. It'll not get called when you hit play. It will get called when you build it. So that means you will have a different behavior between the editor and the build. You never want to do anything in the constructor of a mono behavior, because that way lies madness. You always want to be using awake, enable, and start, as your initializers, awake especially because it happens first in the life cycle of a game object and a component. So in awake, what we do is we check instance. If instance is null, we set instance equal to this. Excuse me. And if instance doesn't equal this, we destroy immediate, and now we have a choice. What we can do is we can destroy this game object, or we can destroy the component attached to it. Now, what we're going to do for this one is destroy the game object. You could just destroy the component. That's a perfectly valid thing to do, is to remove the component from it, but the way I'm going to do this next part, which is the Singleton Prefab, this is required. So let's go through the flow of this. Singleton component, we create a singleton. The lifecycle event goes through. The awake gets called first. Now, we don't have to care about threading in Unity because everything happens on one thread, generally speaking. So, especially lifecycle events, they'll happen one after the other in a frame. So there will be one singleton component will get this awake. See that instance is null, actually. Yeah, so it will see that instance is null, and it will go off and try and get this instance. No, actually, we need that. That's what we need. We need to use the private static rather than the public one, because if you do that, it will go off. It will find one and then create one. Actually, no. I don't think. Actually, no. It doesn't matter. It doesn't matter. We can use the public one. It's fine. It's actually better that way. So when this awakes, it will go off and try and find an instance. The instance will be null at the start. It will go off and try and find itself. So it will find the one that we put in the scene, and it will return it, and it'll go, instance is this, we're going to keep it. Then the next one that we put in will go through, it will check to see if instance is null. Instance is not null because instance is our previous example, and it will return something else. So it will not set it. So now to think about it, I don't think I need this. I think I only need that, yeah. That should just be working. So it'll go off and find out what the canonical version of Singleton component is, and if it's not this, it will destroy it. That's fine. We'll come in here, we'll let it compile. We have a Singleton component. What we will do is we will put some debug statements in here. So there we go. So we're logging if we've got a duplicate, and we're logging if we've not. So now we hit play it. We come out of it, hit play again. It's all working perfectly fine. Now, what happens if we duplicate it? So, this is the way the life cycle works. is that that Singleton object 1 got its awake called first. So it became the canonical version. It doesn't matter whereabouts in the hierarchy it is, that will always be the case. Now, if I move this up here, we'll save this scene, create a new scene. Unity having a bit of a fit. And we go back in, we load up the scene again. We're getting a lot of this shit. And why are we getting all of this shit? Well, that's because we have been setting statics. Unity is having a fit because we have an instance of a static that we deleted. So what do we need to do? Well, we need to do domain reload. No, we'll clear this out and I'll show you what I mean by this. We'll turn off the experimental stuff. And we'll run it. That's embarrassing. I may need to actually restart Unity to completely fix this. I knew this would happen. I knew this would bugger up some way. Because this is the problem that you get when you run with statics. Right, we're going to reload Unity. It'll take a while to reload. Because Unity be Unity. Okay, now if I hit play here, takes a few seconds, does the thing. We'll create our Singleton component. We'll run it. Working fine. Duplicate it, run it again. And we've gotten rid of the errors. So what do we need to do? We need to start thinking about the editor in a script that is going to be run in a thing that isn't the editor. Now this is where the dangerous part of this comes in. So what we need to do is here we need to do a preprocessor command. So if Unity editor we need to take into account when the plain mode state changes. And again, we'll wrap that around that. So what we want to make sure is we don't have any usings up here for Unity Editor, because that will fail on build. So when we're exiting edit mode, what we want to do is set instance equal to null. What we also want to do is on destroy so what this does is when the singleton gets destroyed, it unsets itself, it sets it to null, to actual null. Unity has this weird thing where it has pseudo nulls, and it's a pain in the arse. If you destroy an object, that instance will still point to that object. That's why we're getting the weird allocation errors. But the object doesn't exist anymore. But you've still got a reference to it. So what it does is it overrides the equality comparison and goes, actually, if this is flagged for deletion, just return null. But sometimes it causes weirdness. So you gotta be sure. You gotta make sure you're dealing with that. So this should work perfectly fine. Right, we're going to just put some logs in there so that we can see it in the Singleton component on destroy. Set instance to null so we can see what's going on there. And exiting edit mode, set instance to null. We'll go back into the Singleton Prefab. So this is going to become the basis for our Singleton Prefab. We play, we get that two things, Singleton component. So we'll clear on build, clear on we'll take those off so that we get consistent. So there we go. On destroy the Singleton component, set instance to null. Play mode state changed. There we go. So we'll duplicate that and we'll see what happens. So we deleted the Singleton component. And now we have, mysteriously, two calls to that. Why is that? Well, again, statics. What we also want to do here is unsubscribe from the delegate event. There we go. We're just getting the same thing over and over again. And that's pretty much the most comprehensive Singleton pattern you can get in Unity. That also takes into account our lovely little thing here, which we will now test. We'll press play. Instantly goes into that. Oh, come on, what are you doing? Oh. Yeah, that shouldn't be inside the if. In fact, thinking about it, yeah, thinking about it, that should only be in here. That should be inside that if. And that should be in here. So this is the difficulty in doing this. You gotta be careful where you're doing these things. So yeah, now we don't get the event called at all because we're setting to null on destroy. So there's the on destroy sets instance to null. It also does that. So you might be asking, why are we doing this at all? It's best to be sure. Unity can be a bit finicky and a bit fickle sometimes. So it's best to be entirely sure that when you are changing editor mode, you are doing the basis of a domain reload. So the things that a domain reload would do, as in resetting all the statics, this needs to reset all the statics when you move into play mode. So you want to have this in here to make sure that you are resetting the static when you go into play mode. It's just an arse covering thing. So this is our singleton component. This is all I'm going to do in this singleton component. I'm not going to add any data to this. I'm not going to add any references to this, any properties to this, any functions to this. Nothing. This is singleton component done. All this wants to do is make sure that there is only one of these items. Now, I'm going to delete that. We are now going to create a prefab out of this. And now there is a single singleton prefab. So this is where we get into working within Unity. Unity is based on scenes. You go from one scene to the other scene to the other scene. And what happens is you end up with each scene being its own self-contained thing. But you want to be able to transfer data from one to the other. Now there's lots of ways of doing that. The primary way of doing that is through don't destroy on load, which is the only other thing we're going to add to this. So now that we know that this is our singleton, we're going to do don't destroy on load this game object. Rather than destroy it immediately, we're going to keep it forever. And the reason we've made this a prefab, so if we hit play here, it now goes into a special scene. Hello, Shep. This now goes into a special scene called the don't destroy on load, which means that when we go to another scene, anything that's in this list will remain. So we now have a sample scene. We're going to create second scene. And it's a duplicate of the first scene. So we'll take that button out. Put some text in there. I call that second scene. This is second scene. In fact, actually, you know what? We'll make another scene. We'll make a first scene. And then we have that prefab between them. They're identical. First scene. Second scene. We'll just bin the sample scene. We don't need it anymore. It also means that we don't dick things up with the example singleton. So singleton component, we're going to add a button in here, and that button is going to be go to first scene. And move that down a bit. We're going to do the same in second scene. So we're going to do the same in first scene. go to second scene. Now we're going to create another component on there called scene changer. And we're going to go public void change scene string target scene. This is going to be a very simple script. Scene manager dot load scene target scene. That's all that script is going to do. And we're going to hook it up to the button. But I have put that on the wrong place. We're going to remove that. We're just going to add that to the button. We're going to make the button do the thing. So we're going to change scene to helps if my fingers are on the right keys. To second scene. We're going to second scene. Do the same thing again. Go to first scene. First scene. I actually know that the problem with that is that we have a space in the scene name because I'm an idiot. Now what we have to do is go into build settings and add the scenes to the build so that we can actually swap between them. And now when we play this, you will see that our Singleton component here, click on that, we get our little thing here that says, hey, we deleted a Singleton component. We'll go to second scene, deleting Singleton component, deleting Singleton component whenever we switch scene, because it's deleting the Singleton component that was in here. So the danger now is that we add something else to the click and we reference Singleton component and do something in the Singleton component. That's bad because you're losing references. Now, there are tools to get around this. And certainly this can be used with something called pub/sub, which is going to be the subject of another tutorial that I'm going to be doing probably next week. And pub/sub is a wonderful way of decoupling code. Can be a bit hard to debug, but it is very useful in Unity, especially if you're wanting to use this pattern. So we now have scene changer. It goes between first scene, second scene, and we have the Singleton component. Now, what we want to do with the Singleton component is think about what's useful. So my use case for this is spawning the player in a game. So, for example, you might think, okay, I'm just going to create an object here. It's going to be player spawn. You create a component on that called player spawner. It has a reference to the prefab for the player. And then it goes off and it deals with all the stuff that is required for spawning the player. But, for example, in a game that I'm making, you can have multiple players with all different powers and abilities. What you would end up with is kind of a salad. You have to figure out a way of telling that player spawn what player to spawn. So that player would have to then go off and look for an object that contains all of the game save data. Or it would have to load the game save data itself. Or you get into that kind of way of doing things. It's a perfectly fine way of doing things. The Singleton Pattern, however, is a good way of combining and condensing that all into one object, into one prefab, And what it allows you to do is, on a scene-by-scene basis, change things without changing the initial going from the main menu, creating a new game and going into a level. It saves you from having to do all of that just to test a level. So for example, what I'm going to do here is I'm going to call this game state controller or something. Yeah, we'll just call it game state for now. And we go public game object player prefabs, and it's just a list of prefabs, player number, and what we do is void awake. What happens here is, actually, we'll do it on enable. No, it's scene manager. Again, with the scene manager dot active scene changed. And when we disable it, we change it. We turn it off so we don't listen for it anymore. And what we do in here is we spawn the player. So that's how we would get the player prefab. We would find that, or for example, we don't do that and we just have this be the repository of data, and the scene change, not the scene changer. Where's the thing? The player spawn. I never actually made a player spawn thing. So this is how we would use the Singleton component. So player spawner on start, we would do Singleton component dot instance dot get component game state, and in that we would have our player number, our player prefabs, and what we could probably do here is do this and create a new property on that, and that will return helps if I make that a game object. So this is our basic player spawner. It goes off the start, goes off to our Singleton component, gets the current player prefab, and instantiates the player prefab. So we'll go back into here. We'll create a cube, player 0, and no, deselect that. Create another one which is a sphere and call that player 1. Actually, what we'll do is we'll change this here. Where is that? Oh, that's it. So we'll make them slightly bigger. We'll make them 5x5 so that you can see them. We'll move them down a bit. I'll create these as prefabs as well. So player 0, player 1, we want the Singleton component, I'm going to actually apply that to the prefab. I'm going to Singleton component. We now have player 0, player 1. Come out of that. We now have that in there. So what we can do now is we can set that and override the prefab. And that will spawn a clone of player 1. And then if we click and go to second scene, go back to first scene, we'll do that. And what we can do is we can change that to 0 while we're playing, and it'll spawn the first player. So what this means is we'll copy this player spawn and we'll go into second scene and we'll put the player spawn there. So this player number is 0, so it'll set 0, and we'll go to second scene. So we're now on player 0. Whichever scene we go into, we will spawn player 0. Go into the first scene, we'll override that. Doesn't matter what scene we go in, we're spawning player 1. Now this is how I use the Singleton Prefab. You can have all your defaults in the prefab itself, and you can override on a per scene basis, on a per testing basis. And what this means is that when you, so long as you have, say in your main menu, you have this Singleton component set to your defaults, you can have a start game button that will go off and say to the Singleton component, hey, we're starting a game and you're using player model 1 or you're using player model 0, and then it'll start the game and it'll wipe any new ones it finds. So on a testing basis, you can just be working entirely within this one scene and it will be fine. Now there are different ways of doing this, there are better ways of doing this, but it is a pattern that you can use. It's especially, once you get the pattern down, it's quite newbie friendly. The other ways that I would consider doing this, and just to go off on a bit of a tangent here, is to create a new scene. So the way that Unity does it nowadays, like I think for the past couple of years, you can do multi-scene editing. So what we can do is add a new scene, and literally we can create an empty game object here called game state, and you can have your game state in here. And put your players in here, and you'll save that scene as something like default player setup or default game state, and you'll have that scene as all your default God objects, essentially all your default game state objects, rather than having it in the Singleton component. But this requires you to remember to open up the right setup, and it leads to potential problems when you start working on larger projects. Now, I'm not saying either one of these is the right way of doing it. The whole point of programming is doing it however you feel is most comfortable for you. If you're working in a team, you've got to discuss with your team what you think the best way is and what they think the best way is, and come to an agreement and work within those lines. But this is a tool that you can use, and I'm sure when I put this on YouTube and put this out, there will be lots of people complaining or discussing, and I hope you do, because while I'm here to teach some things, I am still open to learn things. I am by no means infallible. Hell, I'm using singletons for fuck's sake. But I do hope that anyone who's watched this has got something out of it. And next week I will be doing a little bit of an extension on this. Something that's probably people can agree on a bit more. Playing Fidget Spinner World Tour 90. Yes. Fidget Spinner World Tour 90 was a complete meme game that I made, and I love it and I hate it at the same time. But I'm just going to wrap up this just now. We can go off on another tangent later. So, Singleton component, Singleton Prefab. Now, what I would love to do is have it so that rather than in the Singleton component, rather than just going, oh, I'm going to create a new game object with a Singleton component on it, that I'm going to go off and instantiate a prefab. But unfortunately, Unity doesn't give you a good way of doing that. So it is still rubbing against how Unity is supposed to do things. So again, it's not perfect. It's just a way of doing things. And this other way is probably a better way of doing it within Unity itself. And working with Unity and doing it is doing the default player setup second scene and not having it be the default scene. But that requires multi-scene editing, and that can get complicated quickly, and that needs to be planned out as well from the start if you're working in a team. This is really good for game jams, for small games, for single-person devs who just want to test things quickly and iterate quickly. So that's all I really wanted to say about that. And again, I hope you will join me next time for PubSub. Publish, subscribe. It's a really cool pattern, a really cool tool to use for communicating that doesn't require you to hook up objects like the button. So the button hooks up to itself into the scene changer, but what if you wanted to hook it up to the camera? Or what if you wanted to hook it up to something that's not in the same scene? Again, we'll get into multi-scene editing. PubSub is a good way to decouple stuff. So next time, and that'll be next week, I will be doing PubSub, and a very naive PubSub. The week after that, I will be going in and doing some pooling. So pooling is where, for example, bullets in a game. It'll be more of a game dev focused thing, that one. So you try and fire off lots of bullets. Instantiating a new bullet every time is a very heavy operation, and so you don't want to be doing that. You want to be instantiating one, and then when the bullet is destroyed, don't destroy the bullet, just keep it back and re-enable it and put it back and keep firing them and keep reusing the same objects, keep them in a pool of objects and keep reusing them. So that will be in 3 weeks' time. No, that will be in 4 weeks' time. That will be in the new year. That'll be after Christmas. When is Christmas? Christmas is a Friday, so I probably won't be doing a Christmas Eve stream. And I probably won't be doing a New Year's Eve stream, so that'll be the week after. But yeah, so that is Singleton components, Singleton prefabs, and a way of using singletons in Unity. I hope you got something out of it. I hope you enjoyed it. And again, when this goes up on YouTube, comment away and tell me everything that I did that was wrong.